Hello and welcome back to Boxers Shorts, where we take issues from GCSE Science and try and break them down by popular demand. We're going to do titration calculations today. This is a classic area of difficulty that students tend to have. I've got a very simple method that should take us through it. Before we get started, your usual reminder, put your phones away or on silent, close tabs if you're using a laptop, that kind of thing. And I also have an apology to make. I've started using a new app to do these videos, and when I bring my pen close to the screen, I can see a cursor. And in previous videos, I've used that cursor to draw your attention to things, but it turns out that the recording software I use doesn't record that cursor. So there are bits in those videos where I go, yeah, so look over here, and you're like, where am I supposed to look? Because there's no cursor there. So today I'm going to try and use the mouse for that, and then my pen for writing like this. And I'm just going to say sorry. Can we have the R? There we go. Sorry about those previous videos if that came up. All right, let's get started. So here we have a few questions for you to do. These are based on the concentration equation that you should know by now. Do these, please pause the video, do the questions, and then press play when you're ready. Okay, so you should only be listening to my voice now if you have done these questions. Let's start with question number 1, 4.2 moles of solute dissolved in 1.8 dm cubed of water concentration. So we know that concentration equals moles, not males, moles. Moles over volume, which in this case is going to be 4.2. So that's up here in the question, over 1.8. I tried to do that with my cursor again and remembered that it doesn't work. 4.2 divided by 1.8. Punch that into your trusty calculator. And that will give you 2.3 recurring. So let's just go for 2.33 moles per decimeter cubed. Now, ordinarily in the GCSE, they will ask you to give it to a number of decimal places or significant figures. Okay, next up, if you got that right, well done. If you didn't, then I'm hoping that working that I've done for you makes sense over here. And I will at some point do a video on this equation. All right, how many moles of solute are present in 25 centimeter cubed? So the first thing I'm going to do is straight off the bat, I'm going to turn that into dm cubed by dividing by 1,000. And then what I like to do is cross it out from the question. I never think about it again, because all too often students make the correct unit conversion, so they do that correctly, but then they still use that number in their calculation. So if concentration is moles over volume, and I want to work out moles, then moles equals concentration times my volume, and therefore it equals 0.08, which is my concentration, times by the volume, which is 0.025. When I plug that into my trusty calculator, I get 0.08 times 0.025, which gives me 2 times 10 to the minus 3. And that is absolutely perfect. Sorry, let's go away. And then there's no unit for that because it's just moles, which is just a number. Final one. Solution with that concentration. So again, if concentration is moles over volume, then in this case I want to work out volume. So volume equals moles over concentration, which in this case is going to be 0.04 divided by 0.12. So I plug into my calculator and I get 0.3 recurring. Loving those recurring threes today. 0.33 recurring, and that will of course be in decimeter cubed. If you got all those correct, well done. If you didn't get those correct and the working makes sense and you sort of get it now, what I would suggest is you go back, clean away all of your work that you've done and try them again from scratch. And then if you get those, great. If you have absolutely no idea what I'm talking about, this video is not for you. And you'll need to wait until I manage to do a video just on this equation here, but definitely don't progress in this video. Okay, titration. What is the point? Sorry, I think the screen's over here. Here we go. Big question here. What is the point of a titration? The point of a titration is always one thing, and it's, let's go with blue, to determine, which means work out, the concentration of an unknown solution. What do I mean by that? Now, let's say I go to my technician, Mr. Morris, and I say, Mr. Morris, I would like some hydrochloric acid. Mr. Morris brings me a little bottle. It looks like this, and it says HCl on the front, and underneath that, it will say the concentration. So it might say 0.1 moles per dm cubed. And I'll be like, great, I can use that. Thank you so much, Mr. Morris. Now, let's say he came to me and said, sir, I'm really sorry. I've got you your hydrochloric acid, but I do not know the concentration. It is a mystery. We used to know it, but someone's rubbed it off. Someone's moved the sticker. It's vanished. Oh no, I don't know what the concentration is. Okay, so what I need to do is work out the concentration. How do I do that? So I take some of this hydrochloric acid and I put it in a beaker, like that. And I know the volume in that beaker. So it might have, say, I don't know, 25 centimeter cubed. I know it's HCl, but its concentration is a mystery. I then get another beaker, and in that I put some more stuff, but this stuff isn't HCl, it's NaOH, sodium hydroxide. And I know the concentration of this. And I know that this has a concentration of 1.2 moles per dm cubed. Just about squeeze that in. So I've got my NaOH, which is 1.2 moles per decimeter cubed, and I've got my HCl, which is 25 centimeter cubed. Now what I do is I add this into here until it is perfectly neutral. Until it is perfectly neutral. So I've got just the right amount of NaOH for HCl. No more, no less. I.e., nothing is excess, nothing is limiting either. And let's say I do that and I find that I've added 22.5 cm cubed. Why is that important? It's important because I can actually use that data. I can use this, and I can use this, and I can use this to work out this. So again, oh, I should get a highlighter. Can I get a highlighter? Yeah. Let's go get a yellow highlighter. Oh, maybe pink. Go for a pink highlighter. I can use this and this and this to work out that. There it is. Now, students tend to get stuck here because it's can be quite a tangled process. But fortunately for you, I have an amazing method to teach you. And this method will help you work this out, whatever titration question you come across. And the method is called the creepy, violent, I spelled that wrong, creepy, violent monster method. So it's a monster, rah, big scary teeth, rah, going like that, rah. It's the creepy, violent monster method. Why? Because we've got a C, we've got a V, we've got an M. And that is going to be the most important thing for you in terms of working out your titration calculations. So let's take this one as an example. They'll give you information in the question. So all of this stuff that I've given you up here, they'll give you as information in the question. They will almost always also give you the equation. So in this example, NaOH plus HCl forms NaCl plus H2O. To be honest, you should know that anyway, but they'll almost always give it to you in the question. The creepy violent monster method goes like this. You write a C, you write a V, and you write an M. C stands for, what I'm going to do is I'm actually going to move these over a bit, just for this first one. No, I can't really. Shame. So C here stands for concentration. The V from violent stands for volume, and the M there stands for moles. Now, actually, by the way, chemists use the letter N for Nigel when we talk about moles, but for our purposes, we're just going to leave it with M because it's actually simpler and easier to remember. We're not going to stress out about it too much. And you turn this into a kind of table. Oh, actually, I'm just going to get my ruler out and turn this into a little table. So you have a line there. Actually, I don't want to do that. Okay, I want to do it with this thing. Come on, Mr. Boxer, concentrate. There we go. Right. So that'll go there. Here, 0 degrees, 0 degrees, 0 degrees. I'm doing this with my fingers, it's pretty difficult actually. That'll go there. That'll go there. And this goes right down the middle between the NaOH and the HCl, and then it can go away. The first thing you do in the creepy violent monster method is you fill out everything that you know. So for NaOH here, right here's the NaOH, they've given me the concentration that's there. So I'm going to write that in. 1.2 moles per dm cubed. They've also given me the volume, 22.5 centimeter cubed. 22.5 centimeter cubed. Great. Have they given me the moles? No, they've not. I'll get to that soon. What about HCl? Have they given me the concentration? No, that's actually the thing I'm trying to work out. That's my final answer. Have they given me the volume? Yeah, they have. I've got 25 centimeter cubed. Happy days. Have they given me the moles? No, they haven't. What I can do is I can use all of this information now. And because I've got the data down here in the table, I can move away from the picture. They give me, I can use all of this information to work out this. And the way I do it is by going round like that. So I'm going to start up here. I know my concentration and I know my volume. Well, hang on a second. Volume is in centimeter cubed. I don't like that. I'm going to turn that straight away into 0.0225 dm cubed, straight off the bat. And I'm using blue to show you all the stuff that comes after simply putting the data into the table. Moles. Well, actually, we did this. We know how to get moles from a volume and a concentration. We know that moles is concentration times volume. So I'll just do 1.2 from the top here, multiplied by 0.0225 here, times 0.0225 down there. I plug that into my trusty calculator. I'm going to get rid of all this red now. Get the point. Oh dear, what's happened? Rubbed off too much. What was it? It was 1.2. I plug that into my calculator. That gives me 0.027. Okay, so I've gone from here, down to here, down to here. My next step is to go here. How many moles of HCl do I have? Well, I look at the equation and I use a molar ratio. I've got one of these to one of those, which means if I've got 0.027 here, I must have 0.027 over there as well. Nope, no. 27 over there, because it's a 1-to-1 ratio. Now, it won't always be 1-to-1. It might be 1-to-2, it might be 2-to-1, it might be 3-to-2, whatever it is. You know how to use molar ratios, because we've done that in an earlier video. So you get 0.027 there, which now takes you up a step to the volume here. Well, hang on again, it's in centimeter cubed. Let's quickly change that straight away to decimeter cubed. 0.025 dm cubed. And I now have enough information to work out what should go over there. So first I'm going to rub out the question mark, and then I'm just going to do concentration equals moles over volume, moles over volume, which in other words, in this particular case, is 0.027 divided by 0.025. Calculator, and I get 0.108 moles per dm cubed. So I've now worked out the concentration of my unknown solution by going around the houses, starting here, going all the way up, finishing over there, getting that as my final answer, which means it's always good to go back. If I wanted to know the concentration of this HCl, so Mr. Morris said to me, Mr. Boxer, I don't know what the concentration of this HCl is. I've now worked it out. I can write a label on that bottle and it'll be 0.108 moles per decimeter cubed. More importantly, I've just got about 4 marks in my exam, just by following the creepy, violent monster method. What I would suggest is you pause your video and copy down all of that. You don't really need, I think probably the actual monster himself or herself is not necessary in your notes, but I would suggest that you get down all of this, because this is going to be like your template for working out the future ones. So pause your video now and get that down. All right, you should now have copied down your notes and you should be ready to do an actual question. Now what we'll do in this one is, I've got, how many questions? I've got 1, 2, 3, I've got 4. So maybe what we'll do is, in this one, I'll do it again myself. And then in the next one, I will do it. No, I'll tell you what we'll do is, in this one, we'll do it. I'll do a step and then I'll prompt you at various points to do steps yourselves. Okay, so we've got a student doing an experiment finding that 32 centimeter cube potassium hydroxide solution neutralized 25 centimeter cube nitric acid. Wait, what a lot of information. Concentration of dilute nitric acid was that. And now I need to calculate the concentration of potassium hydroxide. Now, the reason why students come a cropper and find these difficult is because they just like really struggle to extract all of the information from here, because you've got so much, like you've got this and you've got this and you've got that and you've got that and then you've got that and then you've got the other. You've just got loads and loads and loads of information in there. It's just too much to take in at once, which is why the creepy violent monster method is so good. So what we do is we write out HNO3 and we write out KOH and we draw a table. I'm not going to bother faffing around with the lines this time because I don't think it was worth it. That looks a bit like this. What I would like you to do is copy that down and fill out what goes here, what goes here, and what goes here. Pause your video and fill out what goes in those boxes. So I'm hoping that you filled out your creepy, violent monster method. C is concentration. HNO3, do I know the concentration of nitric acid? Yes, I do. It says so in the question over here. The concentration of the dilute nitric acid was 3 moles per decimeter cube. Cool. I can put that in over there. Outstanding. Do I know what the volume was? Have a look, see if you can figure it out. What was the volume of nitric acid? Say in 3. 1, 2, 3. 25.0 centimeter cubed. Beautiful. Do I know how many moles I've got of nitric acid? Yes or no? Say in 3. Do I know how many moles of nitric acid I've got? 1, 2, 3. The answer is no, not yet. I don't. And then I don't know the number of moles of KOH either. Do I know the volume of KOH? Do I know the volume of KOH? 1, 2, 3. Yes, I do. It says it up here. 32 centimeter cubed. 32.0 centimeter cubed. Now I'm going to go around the houses like I did last time. I'm going to go all the way from there, around here, and then up there. Oh, I should have made clear, of course, this is our question mark. That's what we're trying to work out. That's my target. That's what I'm getting to. First thing I'd like you to do is convert this to dm cubed. Convert that to dm cubed. I'm hoping you got 0.025 dm cubed. All right. So how many moles have I got? Well, I know that moles is concentration times volume. So I'll do concentration, which was 3, times by my volume, which is 0.025. Plug that into my calculator. And I get 0.075. Okay, well, how many moles of KOH do I have? I'd like you to look carefully at the question and tell me how many moles of KOH there are. How many moles of KOH are there? 1, 2, 3. I'm hoping you wrote, go away, it keeps doing that, 0.075. Why? Because it is a 1-to-1 ratio. Okay, what's the volume here? What's the volume in here? I'd like you to work that out for me, please. Write down your answer. What is the volume over here? I'm hoping that you got 0.0320 dm cubed, which means I am now ready to work out my final box, which you can do for me. Work out the final box. So we know that concentration is moles over volume, which is 0.075 divided by the volume, which is 0.0320, and that will give us, get rid of this stuff, get out of the way, make it nice and neat, to get 0.075 divided by 0.032, and that'll give me 2.34 moles per dm cubed. Voila, 4 marks in an exam. Easy peasy. If you got all that and that made sense to you, I'm very happy. If it didn't, I suggest you go back over it, do it nice and slow. And then maybe if you're still not sure, what you could do is you could rub out all of your working and try and do it yourself, knowing that that's the correct answer. If you do have that right and you're ready to move on, let's have a look at this one. And what I'd like you to do is try this one for yourself, and then I will go over it. So pause your video, do this one for yourself. Okay, you can only be listening to my voice if you have done this question. And what I'm going to do is I'm going to work through it quite quickly now. I've got NaOH and I've got HCl. I've got my creepy, violent monsters. I came up with the name of that method by myself, guys. I'm quite proud of it. Right, do I know the concentration of sodium hydroxide? Yep, it says here I've got 0.2 moles per decimeter cubed, so 0.200 mole per dm cubed. Do I know the volume? Yep, 24.20 cm cubed. Do I know the number of moles? Not yet, but I do know the volume of HCl. That's 6.50 cm cubed. Start to go around the houses following my monster method, of course. Up there. And I get moles is 0.2 times by 24.2. That gives me 4.84. What's my molar ratio? It's 1-to-1. So I can see there's one of these to one of those. So this is also going to be 4.84. Oh, God, I made a mistake. I hope you're yelling at the screen and saying, sir, screw it up. This is not 24.20. This should be 0.0242 dm cubed. You have my sincerest apologies. And therefore, it was 0.200 divided by 0.0242. Let's try that again. So embarrassing. 8.264. So I'll put that here as well. Much to my embarrassment, I can't believe this. Like, this is an absolute disaster. The number of mistakes that I'm making, because of course it's not 0.2 divided by 0.0242. It's times together. Nothing is going right today. Let's try again. 0.200 times by 0.0242. God, this is so embarrassing. 0.2 times 0.0242. I've just lost like 1 million subscribers. That gives me 4.84 times 10 to the minus 3. And this, of course, is a 1-to-1 ratio. Hoping you did this better than I did. This is 6.5 centimeter cubed, so it's 0.0065 by dividing by 1,000. The m cubed, I then do 4.84 times 10 to the minus 3 divided by 0.0065. And that should give me 0.745 to 3 significant figures, mole at the m cubed. Got there eventually. That's rather embarrassing, I would say. Okay, yeah, fine. Next one. Hopefully we'll be able to do this one without me making too many mistakes. Same drill as before. Pause the video, do the question. Okay, I'm going to try it myself now, and hopefully I'm not going to make too many errors like I did last time, rather embarrassingly. Never going to live it down. And then OH, creepy, violent monsters. Okay, concentration of vinegar. I don't know this one. It's a question mark. See, they give me the volume, but they don't give me the concentration. So I know the volume is 25.00 centimeter cubed. And you know what? I'm just going to change that now before I make the same mistake I did last time. 0.02500 bm cubed. I don't know what the moles is. That's completely unknown to me. Then I've got sodium hydroxide. So I know the volume and I know the concentration. So the concentration is up here. Excuse me. 0.40 moles dm cubed. And then underneath that, I've got the volume, which is 32.50 centimeter cubed, aka 0.03250 dm cubed. Now, in terms of going around the houses, I'm going to have to go around this way this time, which is absolutely fine. It's not a problem. Doesn't really make much of a difference. To get moles, I do concentration times volume rather than screwing it up like I did last time. So 0.4 times by 0.03250, which gives me 0.013 moles. What is the molar ratio? Looks like it's 1:1 to me. So again, 0.013 is going to go over there. I've got my volume. What's my concentration? It's going to be moles divided by volume. So 0.013 divided by the volume, which is 0.025. And that gives me 0.52 moles per em cubed. Happy days. Hopefully I got that right and I didn't make any mistakes this time around. So embarrassing. Right, have I got any more of these ones? Yeah, there's one more here. Try this one for yourselves, please. I should make that a bit smaller. Okay. Pause the video, do that one for yourselves. Okay, you should only be listening to me if you've done the question. Now, by the way, some of the weird units here, like where it says moles per cubic decimeter there, or where in the previous one it said, what did it say? Yeah, it was here moles / dm cube. That's because I took these questions from other sources that sometimes are quite old, and they tend to use like a bit of a mismatch, a mashup of what's it called, of units. I'm actually just going to make this a bit smaller so I've got more space to write in. And I'm going to see if I can make this bigger so it gives me even more space underneath. Lovely. Right, so again, I've got my H2SO4, my sulfuric acid, and I've got my NH3. Creepy, violent monsters. Scary, scary, scary. Right. Concentration of sulfuric acid is 0.025 moles per dm cubed. So it says so up here. By the way, you notice that when I do these, I don't highlight anything. There's no point, right? You end up just highlighting everything that's important and then going back and having to look for them again. Like, it doesn't really help you. So that's why this table is so strong, because what it means is that at each point, I'm just looking for one thing. So here I'm just looking for one thing. Here, volume of H2SO4, like I'm just looking for one thing, and it's over here, 44 centimeter cubed of sulfuric acid. So 44.0 centimeter cubed, which I'm just going to change straight away to dm cubed, and the number of moles I don't know yet. I obviously don't know that. That's my unknown, because it wants to know what the concentration of ammonia solution is. Do I know what the volume of ammonia solution is? Yep, it says 15 centimeter cubed. That's up here. Right, which I'm going to change straight away. Okay, time to get working. I'm going to go around the houses from here around this way. So moles is concentration times volume, so 0.025 multiplied by 0.044, which gives me, where's my calculator, 1.1 times 10 to the minus 3. What's the molar ratio? It's 2 to 2, which is the same as 1 to 1, so I don't need to do anything to that. I'll just put 1.1 times 10 to the minus 3 over there. I've then got my moles, and I've got my volume, so I can work out the concentration, get rid of that. So I just do moles divided by volume, which is 1.1 times 10 to the minus 3 divided by 0.0150. It gives me 0.073. Recurring more of these 0.073s. Mole per dm cubed. Done. I don't think I've got any more examples of that. Right. If you got that and you're happy with that, fantastic. Well done. Let's move on. If you're not, you've got to go back. Do these again. I've given you all the working. I said all of my steps aloud. So please do make sure you go back and do those again. The next bit is just to talk about examples that look like this. So read through that first. Pause the video, read through that. Okay, you should only be listening to me now if you have had a chance to read through that. You can tell the only difference excuse me, between this and the previous one is that this one seems to have loads of results like this. And the reason for that is because we don't do a titration once, we normally do it a few times until we get what are called concordant results. And concordant results are within 0.1 centimeter cubed of each other. So the difference, for example, between these two is like 2.4 centimeter, but sorry, here's the cursor again. The difference between these two is 2.4 centimeter cubed. So you don't want to use them, they're too different. The difference between these one is 1 centimeter cubed. So you don't want to use those, they're too different as well. But if you look at these two, they are within 0.1 of each other. So 0.1 to 0.15 is within 0.1. And the same here. So 0.15 to 0.2 is within 1, and 0.10 to 0.20 is within 1, 2. So what we'll do is we'll just say, right, these are the ones I'm going to use. And then the first thing you do is you work out the mean. So we'd go 21.1 plus 21.5 plus 21.2 divided by 3. Plug that into your calculator. No, sorry, I wrote 21.5, it should be 21.15. And that should, of course, give you that middle value. Sorry, middle value anyway. What's happened here? Divided by 3. That should give you 21.15, which you could have done just by eyeballing those. Okay, and that's your volume of sodium hydroxide. All right, let's go around the houses and do the creepy violent monsters. So we've got NaOH, and we've got H2SO4. I would like you to do that one yourself, please. So you should by now have done that question. I forgot to say pause your screen, but you should know that by now. You should have paused your screen to do that one yourself. It's time to do our creepy, violent monsters. Like so. What do I know from the question? Concentration of sodium hydroxide, that's given to me up here. 0.115 moles per dm cubed. Volume of sodium hydroxide, well, that's what I got from this table. So that's this, the average value, which is 21.15 cm cubed, which I'm going to change straight away to 0.02115 dm cubed. And my number of moles then, I don't know yet. I also don't know this, that's my question mark. But I do know my volume of sulfuric acid because it says I've got 25 centimeters cubed. or 0.025 dm cubed. Got that from there. Time to go around the houses. So just times those two together. What I'll do is I'll make this bigger so you can see what I'm doing, because we don't need the rest of the question now. We've got all the information we need. 5 times 0.02115. That gives me 2.43225 times 10 to the minus 3. Oh, hang on a second. This bit is going to be a bit different because my ratio is a bit different. My ratio now is 2 to 1, which means I've actually got to divide this by 2 to get from one to the next. And that gives me 1.216125 times 10 to the minus 3. And then do that divided by 0.025, 0.0486 moles per dm cubed. 5 marks in the bag. If you got that right, you got 5 marks. Well done. I suspect that some of you went wrong over here with the ratio, because we've only done 1-to-1 ratios before. I really should have given you a 2-to-1 already, but it doesn't really matter. We know that we've got 2 NaOHs for every 1 H2SO4, so that has to be divided by 2. If you got that right, bravo. If you got it out by a factor of 2 because you forgot to do this, then that's still pretty good. Okay, we're now ready to do the last example, which looks a bit like this, and it uses an acid which will probably be new to you. Much better, because all the information you need to answer the question is provided for you. What I'd like you to do is pause your video and do this question for me. Okay, you should only now be playing the video if you have done this question. So the first thing I'm going to do is I'm going to work out the concordant titers, which is this, this, and this. So when I punch those into my calculator, I get 12.13, and then all of these occurring 3s again. I'm now ready to do my C6H8O7 over there, NaOH over there, and my creepy violent monster method. Oops, sorry. Okay, so let's start mining the question for information. So I don't know the concentration of citric acid. That's a nice question mark. I do know the volume of citric acid. That's given to me over here. That's the 12.133. That's what I just worked out. Or 0.012133, yada yada. dm cubed, because that was in cm cubed. Moles I don't know yet. Concentration of NaOH, I do know because it tells me it's 0.102 moles per dm cubed. Great. And then the volume of sodium hydroxide is 15.0 centimeter cubed, aka 0.0150 dm cubed. I'm going to go around the houses in this direction, like we did in that previous example. I'm going to work out the moles of NaOH that I've got. So moles is concentration times by volume, so 0.102 times by 0.0150. That gives me 1.53 times 10 to the minus 3. Now my molar ratio here is 3 to 1. I've got 3 in the question here to 1 there, so I actually need to divide that by 3. I'll divide that by 3 and I'll get, sorry, hang on, 1.53 times 10 to the minus 3, divide that by 3 and I get 5.1 times 10 to the minus 4. And then the concentration is moles over volume. So 5.1 times 10 to the minus 4 divided by the volume, which is 0.012, etc. And that gives me enough, clearly not got enough room to write this down in that itty bitty tiny box. 10 to the minus 4 divided by 0.012 That gives me 0.0425. I'll write that over here. 0.0425 moles per dm cubed. That is the end of the titration video. I hope you've enjoyed yourself. I hope you feel like you've learned something. And remember, please do subscribe and let me know in the comments if there's something in particular you want me to do.